Hey everyone. Hey Jay.
Hey, Justine, thank you for being here with me, and I'm happy to be here with you. Hey, everybody, I'm Jay Gordon.
Hey everyone. I'm Justine Cocchi. I'm a program manager in the Cosmos-db team. I work on a lot of areas in our SQL API, including the .NET and Go SDKs, Query, and of course the integrated cache, which is what we're here to talk about today.
Brad, and I'm Jay Gordon. I am a senior program manager with the Cosmos DB team, and I'm pretty much focused on reaching people like yourself. I want to reach out to developers. I want to be part of the community conversations, and I really would love to make sure that you understand why Cosmos DB makes the most sense for you and the applications that you build. Uh, Justine, I know you pulled me in here real quick. Your previous co-host Alex couldn't make it today, and you tapped me on the shoulder via Teams. I came running, and I'm super excited to learn more because I'll be honest, like I've only used a few different types of caches when I worked in server technology. And so understanding the Cosmos DB integrated cache, it's a long way from where I was, installing memcached on servers and just connecting that into web apps. So I'm super excited to learn about it.
Cool. Yeah, I'm really excited too. So let's dive into it. Let's go ahead and meet our moderator. We have Glenn here today who will help moderate our chat and take all of your great questions for the day.
And the Learn module implement integrated cache in Azure Cosmos DB SQL API. This is the meat and potatoes of this session. If you want to go ahead and you want to follow along with us, go ahead and get to that QR code or go to that URL. I know our producer Jason, who is wonderful, will make sure that that link gets shared with you in the chat as well. And you can go ahead, you can complete the interactive learning, you can gain experience points so you can become a level 15 Azure wizard, and really take part in the learning path that really we're super proud of. It gives you that free education that we're really looking forward to making sure that you have. And we also have a certificate, don't we, Justine?
Yeah, there's a certification. So if you're interested in really testing your knowledge of Azure Cosmos DB, go ahead and take this certification. There's a QR code and another link here. This is really great for candidates that have solid knowledge and experience with Cosmos DB and will really help you test your skills and make sure that you know how to build applications on the database.
Yeah, and one of the things that I come from, I guess, a time where certificates and getting certified was such an important part of your career. Nowadays, it's really a decision that's left up to the individual and how much they feel like it's necessary. But what I always felt about this, Justine, is that it's nice to be able to have that little stamp on your LinkedIn or
Yeah.
be able to, throw it on your resume. And to be honest with you, a lot of organizations will actually appreciate you going out of your way to say, you know what? I don't just know how to use this. Here's the company that made it, that certifies the fact that I do understand how this works. And so it can only really benefit you. So go ahead, go get certified. The URL and the QR code are all there. And I'm sure our marvelous producer, Jason, will put that in the chat as well. So, how about we start talking about our learning objectives, Justine? What do you think?
Yeah, totally. So we have two learning objectives today. The first is to learn how to implement the integrated cache, right? The most important thing when you have the cache is knowing how to actually use it and getting the best out of the cache itself. And along with that, we'll show you how to configure some of the cache options. So how can you really test the performance of your cache and make sure that all of your options are configured properly, exactly how you need it for your application?
So I have a question before we kind of get into that, if you don't mind.
Oh,
Uh,
yeah.
the one question I have, it really has to do with that the term cache. We talk about it a lot in the context of being able to reduce server load, especially on read operations. Uh, how did it really become like a bigger part of the Azure story? Is it just the fact that we produce this? Is there a reason why people would choose this over, say, using like a Redis service, which I've known very well in the past, along with like even what I said, Memcached.
Yeah, totally. So there's a lot of caching options for your application, of course. But what makes the integrated cache really stand out for Cosmos DB? And again, we'll get into this in the meat of the session, but it is an integrated cache. So this cache is directly into the Cosmos DB gateway, and it is in memory. You don't need to change your application code at all. You don't need to make extra calls to Redis and Cosmos DB. It's just really integrated right there in your application. So it's super easy to use and is optimized for reducing your RU for read requests in Cosmos DB.
Very, very cool. And so I know that we are a live and interactive session. And so I want to give some shout outs, but first, why don't you go ahead and just give us a brief introduction of what people can expect to be doing alongside with us.
Cool. Yeah. So this is a live session. We are really here talking to you, and we would love to hear from you. So if you have any questions, please put them in the chat. We'd love to answer them live on screen. And again, this is part of the Learn Live module. So if you want to follow along or maybe just listen to all of our great content and do the module after, that would be great. We really love your participation, and we really want to hear from you.
Yeah, and let me give some shout outs. We've got some really good people that are really excited about being part of this session. And that's what this whole live and interactive thing is all about. We want to hear from you. Our community is just as important as the technology that we were talking about and promoting, making sure people understand how they can reach out to resources. And that's what we are right now. We're a resource. And I want to give a big thank you to Glenn, who's in there being that resource for everybody. And so Bala, Die Hayes Flyer, Martin, Saket, Fuel, thank you so much for taking part in our live and interactive chat. We really appreciate your involvement. We really need you to be involved because that's why we're doing this. So I think we're ready to get into our introduction, aren't we, Justine?
Yeah, let's do it.
So read-heavy workloads can run into situations where small request unit charges can add up in the aggregate and cause the developer team to write custom code to cache the responsive read operations and queries. Implementing a client-side cache can become cumbersome. Just really quickly, this can become difficult for you. And the integrated cache feature for Azure Cosmos DB is a solution to enable caching while having to write custom code. And that's really important because the more custom code that you're writing, the more things that you have to maintain. And ultimately, that maintenance ends up putting operational overhead on not just you, but the entire organization that you work with. And so in this particular presentation and the module that you can run through on your own, you're going to learn about the integrated cache, its configuration, and the strategies to monitor it. And so when you're done with this module, if you've run through it on your own or if you watched what we're talking about, you know what, Justine, we're going to be able to tell them that they're going to know how to do two things. You want to know what they are?
Yeah.
They're going to learn how to implement the integrated cache, and they're going to understand how to configure those integrated cache options. And I know you've got so much great information for me. And to get into it, I think it's time for me to talk about what the integrated cache is. What do you think?
Yeah, I think that sounds good. We've been talking a lot about this integrated cache. I'm dying to know what it is.
Yeah, well, I have been dying to talk to you about it, and that's what we're going to do right now. So configured on dedicated gateway, which is a server-side compute that is the front end to your Cosmos DB account. When you connect to your dedicated gateway endpoint, your application sends a request to that dedicated gateway, which will then route them to the different backend partitions. So we're not directly just putting in our connection string. Is that right, Justine?
Yeah, exactly. So the dedicated gateway is actually separate compute that has its own connection string. And if you want to use the integrated cache, you go through the dedicated gateway. So they kind of come together as a package deal.
So it's as the slide says, it's an in-memory cache that's automatically configured with the dedicated gateway, and the cache has two major components, and I'm going to talk about those really quickly. But before I do, I want to remind you that we have an eviction policy that is for your documents across both components, and it's least recently used, or also known as LRU. So just to make sure that you understand that there's a way of handling evictions. But let's talk about item cache first. It's used for point reads, like key value lookups based on an ID and a partition key. And it's great for new writes, updates, and deletes that are automatically populated in the item cache, as well as items in your app that try to read what isn't already in the cache. And then let's talk about the query cache for a second. The query cache transforms a query into a key value lookup, where the key is the text and the value is the query results. No query engine in the cache, not necessary. If the cache doesn't have the result for the query that we've sent to it, it will be sent to the back end and store those results back in the cache. And you can use best practices with query cache for query pagination that are the same. The query cache will automatically capture continuation tokens as well. So that go ahead, Justine.
Yeah, that's right. So that basically means that the query cache, it doesn't have any query parsing logic. It basically stores the query text as the key, and then the results of the query are the results that get served back to you. So you don't need to worry about any different pagination or any extra code. The code that you already have for the normal query will work with the dedicated gateway, and the continuation token will be handled for you. So you don't need to do anything special to make sure that your continuations on your query work. If you're using the dedicated gateway, your queries will just work as is. If for some reason the query isn't cached, maybe it hasn't been run yet, this is the first time it's being run within a certain staleness window, then it will go to the back end and actually fetch those results. So this is really key. These two components make up the total volume of your cache. So that eviction policy that we were talking about will apply across both of these items. So both the item cache and the query cache, the eviction policy will just evict whatever was least recently used across both of these two caches.
So we've got a really good question before we get to the next section, but I want to answer, or I want to cover one more thing. So Martin, we will answer that question in just a second. But first, I want to just talk about the connectivity modes. And so if we move forward to the next slide, there's a really great kind of representation of how everything is flowing from the actual client request all the way through, just accessing Azure like you would with any other HTTP call. And then we're moving forward to the Cosmos endpoint. And once we pass that endpoint, we're going to be given some options to use our gateway node that it's going to do a lookup. So if you've connected to Azure Cosmos DB using gateway mode, you've used the standard gateway. And while Azure Cosmos DB backend, and this is your provision, throughput, your storage, has a dedicated capacity per container, the standard gateway is shared among many customers. I know it's a little convoluted. We'll talk about it a little bit more. It is practical for many customers to share standard gateways, since the compute resources consumed by each individual customer are minimal. Because the integrated cache is specific to your Azure Cosmos DB account and requires significant CPU and memory, it requires a dedicated gateway node. And so Martin Messer in our YouTube channel, he's asked a question, which is, what is a dedicated gateway? You want to give us a little brief intro on that?
Yeah, that's a great question. So a dedicated gateway is basically server compute that acts as a front end to your Cosmos DB account. So you see in this graphic, we have our gateway nodes and our backend nodes. So for traditional gateway mode, you would hit what is called, the Cosmos DB gateway. So this is shared across all customers and everyone can use the gateway, or you can connect with direct mode if you're using our .NET and Java SDK through TCP to directly go to those backend nodes. But when you have a dedicated gateway, you're no longer using that shared gateway, which is that multi-tenant thing that is shared across many accounts. You actually get a dedicated gateway nodes for your account specifically. So the diagram would be exactly the same, but imagine now instead of the green dot being a multi-tenant gateway that's shared across all accounts, it is specifically dedicated gateway for you and your account. So you can provision this for your own account, and it will serve all of your requests. So still the client will be in gateway mode. It will use HTTPS to connect to that green dot, and then it will either have a request that can be served from the cache. So there's no integrated cache on the standard gateway. But if you have your dedicated gateway, you have, those resources are reserved only for you. So we offer that cache. Either the request will be served from the cache, so directly from the gateway cache, or the request will use TCP to go to the backend nodes. So the dedicated gateway is, basically the same as the standard gateway, but it's just compute that's reserved for you.
So before we jump into our next section, we have one more question that's kind of relevant to what we were talking about, eviction policy, which is least recently used. Rogue Cow Moo wants to know, is there a way to configure some data not to be evicted from the cache?
Not to be evicted from the cache or not to be entered into the cache?
Evicted. So things that you want to have as a long-term item in the cache.
Yeah, so there is a concept of cache staleness. So if you had a particular item that you wanted to stay in the cache for a very long time, you can configure the cache staleness to be very long. So this will basically avoid having to go to the backend to refresh. But as far as I know, there's not a specific way to get around the least recently used concept. So if you have an item in your cache that's taking up space but is not accessed very often, it will get evicted if your cache fills up on size. But that's basically, what you would want, right? You would want things that are being constantly used, things that are hot to be in the cache, and an item that maybe isn't used as much. You wouldn't want that to take up space against something else that could potentially save you money.
Gotcha. And we had someone ask about it, and I sent Jason a link so he can share it with you all. They wanted to know what the cost of a dedicated gateway is, and all these are done by cost per instance and region. You can see that there are different options based on exactly how many vCPUs that you need associated with your dedicated gateway. And so we're talking about, for a 16 megabyte memory for vCPU, which is our GPD4, that's like 0.42 cents per hour. Our general purpose one, which is the D8, that's 32 gigs of RAM, 8 vCPUs, that's 0.84 cents per hour. And then our dedicated general purpose D16. So this is the big one, 16 vCPUs, 64 gigs of memory. It's $1.68 per hour. You've also got some your local currency. You can check what that is. But yeah, we've got lots and lots of great options for you. And, cost is all based on utilization as always. So how long you use it is how long you'll pay for it.
Right, however long you've provisioned those nodes. And we'll get into, we'll go into the portal in a few minutes, and we'll show you all of those SKUs and how many nodes you can provision, and we'll get into all of those details for sure.
So now let's move on to the next section. And before we do, I just want to remind everybody we've got a great moderator who's going to answer your questions if we don't get to him right away. And if he doesn't have the answers, he'll get in touch with somebody, and we'll make sure that you can reach out to us on our social medias. We put that at the top end. We'll talk to you about it at the bottom end of the show. And let's also just remind one another that we've in a really great kind of community setting. So we're kind of asking you be great to each other in the chat, be cool. Anything you wouldn't say to someone that you love, don't say to someone else in the chat. Not that anybody's done anything wrong, but I want to remind you, we're adhering to the Microsoft Events Code of Conduct, and I always like to tell people just keep that in mind, because you never know what you'll say and when you'll say it, and it you don't want it to come out badly. So anyway, let's move on.
Good reminder. I think, we want to be an inclusive community. So we're happy that you're all here with us. And now let's review some of the workloads that can actually benefit from the cache. But before we do that, let's think back. We were talking about, oh, well, what if I didn't want to use the integrated cache? What if I wanted to write a custom cache or use Redis or something like that? So what would that actually entail? You would have to make sure that all of your requests are actually routed through your custom cache. You're responsible for scaling out your cache compute to levels that keep up with the scale of Cosmos DB. You're having to handle all the cache invalidation when the items are updated or deleted. And of course, if you have, operations that create one or many items, this also increases the complexity. So managing your own cache could be really complex. And could take a lot of extra custom code. So the Cosmos DB integrated cache is built in. You don't need to do anything to configure it, and it's really great to save you money on read requests. But does that mean that every workload in Cosmos DB can necessarily benefit from the integrated cache? Well, there are some workloads that will benefit far more than others. So let's talk about a couple of them. First, workloads with far more read operations and queries than write operations. So the integrated cache caches, of course, caches point reads, and it caches queries. So if you have a super write-heavy application, while your requests will still work, they'll pass through to the backend and they'll do their writes. You're not actually gaining much from that cache. You're not able to, read that data. So the cache is really for optimizing reads. Along with this, workloads that read large individual items multiple times will see more benefits than workloads that are reading small items. So Cosmos DB, 1 kilobyte point read is 1 RU. If you have larger documents, your RUs to read those documents will also increase. So if you're reading really large documents, instead of going to the backend and incurring all of those RU charges, if you can serve that request from the cache, you'll see much better RUs. It will actually be 0 if it's served from the cache. And also this goes along with, workloads that execute queries multiple times with a large amount of RUs. So the key here is repeatability. If you have read operations and queries that are repeated many times, then that is what will really save you. Instead of going to the backend every time, you'll be able to serve your request from the cache, which of course is 0 RU. So that's what we want.
And if you are curious about the RUs and how many you need to provision based on what your workload is, there are some really great resources that are out there. One of them is the request units in Azure Cosmos DB doc. That's really useful. And then we also have our Cosmos DB Essential series on YouTube. That's another great spot where you can actually get the basics of what is a request unit, an RU, and why you need to consider how they're utilized when you're putting together your full solution for your Cosmos DB powered application. So it's always important to think about your hot partition keys. It's always important to think about how you're going to actually choose your partition key itself. And I have a question for you, Justine.
Okay.
So it's not a gotcha, I promise. But I know we're mostly focused on talking about the SQL API today.
Yeah.
Is there support for this for something, say like our MongoDB API or Cassandra API?
Great question. So today, the integrated cache and dedicated gateway are only available on the SQL API. Adding support for other APIs is on the roadmap, but we don't have any ETA or any solid plans on when that will be available.
The long and winding road of new product and product enhancements. I understand.
Yeah.
Um, so we've got our next section,
Yeah,
and
actually, before we move on, I
oh,
wanted to mention one more thing about the last bullet. So, workloads that
okay.
have hot partition keys for read operations and queries, this is a really great benefit for the integrated cache. So, as we all know, Cosmos DB is a distributed database, which means your data is distributed across many physical partitions. Now, in Cosmos DB, you set a number of RUs, and the number of RUs that you provisioned is evenly divided across all of your physical partitions. So, what if I have a workload with a lot of repeated point reads or repeated queries on one single hot partition? Traditionally, this would create a hot partition, and you might see throttling. So you might actually see requests that can't be served because all of your requests are going to one physical partition. Well, if you have an integrated cache in front of your Cosmos DB account, the integrated cache actually thrives on repeated reads and queries. So in this scenario, it's actually the dream scenario for the integrated cache. So instead of something that used to be sort of an anti-pattern that would lead to hot partition, really not letting you saturate your RUs, if you can serve these requests from your integrated cache, it would be 0 RUs for each repeated read. So if you do have a hot partition, obviously the first best thing is to really think about your partitioning strategy. Is there a way that you can repartition your data and sort of avoid those hot partition queries? But another possible avenue is adding an integrated cache.
Gotcha. So we're going to talk about how to enable that integrated cache in just a moment. But I just want to let everybody know we're getting really, really close to some demos. While we're doing the demos, know that you can do a lot of this stuff on your own as well. The Learn module has so many interesting things that'll get you through each step of this. The docs that we have on Microsoft Docs are also really great step by step. So the next portion we're going to talk about is enabling the integrated cache, and I'd love to hear more about that, Justine.
Yeah, so to enable the integrated cache, you need two things. First, we've already mentioned this, the integrated cache is built into the dedicated gateway. So without the dedicated gateway, we wouldn't have a cache. The first step is to actually go ahead and create that dedicated gateway in your SQL API account. As we mentioned, this is only available for SQL API accounts as of now. And the next thing that you'll need to do is update your SDK code to use the gateway for requests. So you might be thinking to yourself, wait a minute, you spend a lot of time in the beginning telling me I don't need to change my code at all. Well, that is
Mhm.
true, but there are a couple configurations that will need to be made in the SDK that if you're using direct mode, for instance, of course, we'll have to update that to gateway mode in order to take advantage of the gateway. The changes should be very minimal, and in some cases, might be changes that you already have in your application. So let's first dive into how to actually create the dedicated gateway. Now, this is a screenshot from the portal, and I promise we will jump to the portal in just a second. But first, you need to provision the dedicated gateway in your account. So in your Cosmos DB account, there is a blade called dedicated gateway. And when you get to that blade, you should see, if you don't have your dedicated gateway provisioned already, this sort of toggle button at deprovisioned. Well, as soon as you toggle it, it will let you pick the SKUs and the number of instances. Now, Jay was telling us a lot about the SKUs just a moment ago. So let's actually dive into the portal and let's see for ourselves what the dedicated gateway SKUs are and how this all works. So you can see here, I'm in my Cosmos DB portal. This is sort of the control panel here. I've clicked on the dedicated gateway blade. I'm just going to collapse that to give us a little bit of more space on the screen. And I'm going to toggle over to provisioned. So this isn't provisioned until I actually hit save. So I'm not really provisioning anything right now, but I just want to show you all of the options. So as Jay mentioned, there's 3 options, 3 different SKUs that you can provision today. The first has 4 vCPUs and 16 gigabytes of memory. We have one with 8 vCPUs and 32 gigabytes of memory. And then lastly, our biggest SKU that we offer is 16 vCPUs and 64 gigabytes of memory.
The monster gateway.
Yeah, definitely. So this is great if you have, a huge workload and you just want to process a lot of requests. Definitely recommend fine-tuning the SKU based on your workload's needs. Now, the other thing that's important when you're picking a SKU is also the number of instances. So you can go anywhere from 1 to 5, and this is how many physical nodes are actually in your dedicated gateway. So say we provisioned 3 instances, and let's say we pick the middle option with 32 gigs. So what does that actually mean for your dedicated gateway cluster? Technically, this does mean that you have 96 gigabytes of cached storage, but our cache isn't replicated or partitioned in any way. So the cache that's on each node is actually completely independent. So you're not actually able to store, likely won't be 96 gigabytes of distinct data, but that integrated cache is contained to each instance. So the requests will be routed in a round robin fashion, and the instance that you happen to hit will be the cache that serves you. So effectively, it is that 32 gigabyte. Just wanted to call out that topology. Sometimes it could be a little bit confusing when you have the number of instances to think about how that actually interacts with the amount of data that's available in your cache. Cool. The other thing to point out with the number of instances is availability. So if we only have one node, of course, it won't be as highly available. As we know, with everything in the cloud, it's best to plan for failures. We don't expect them to happen. We don't want them to happen. They don't happen very often, but it is possible, right? So if you only have one node provisioned, your availability might go down. We always recommend for production workloads to have 3 or more nodes to really make sure that you can service your requests.
Very, very cool. We're moving on along. I want to remind everybody, as always, before Justine continues, hitting that chat if you've got questions about what we're doing. If you want to know more about the subject, we want to hear from you. So head over to whatever your local chat window is, pop in your questions. We've got Glenn. He will help us out as well. Anyway, sorry, Justine. I just kind of wanted to remind everybody.
Yeah, cool. Thank you. Okay, so now that we've provisioned our dedicated gateway, the next thing that I told you had to do is update your .NET SDK code. So there's really only 3 changes that you need to make sure that they're true. So if they're already true, no updates are needed. The first is actually using the connection string. So we mentioned this in the very beginning, but your dedicated gateway has its own connection string instead of the typical connection string for your account. What really changes here is the endpoint. So instead of hitting, the standard gateway or the backend nodes directly through direct mode, you need to provide the connection string that is for your dedicated gateway. We'll show you what this looks like in just a second. And next, you need to make sure that your connectivity mode is correct. So there's gateway mode and there's direct mode. Of course, if you're using the dedicated gateway, it shouldn't be a big surprise that this needs to be in gateway mode. If you have direct mode, your requests will still work. We didn't take away direct mode, but it won't use the gateway itself. So if you think back to that image that we showed you, with direct mode, you're using TCP connectivity directly to the backend nodes, and it kind of bypasses the gateway altogether. Now, if you're using the Python SDK or the JavaScript SDK, gateway is the only option. So good news, there's no changes needed if you're using those SDKs.
Very cool.
Yeah. And the last thing is the consistency level. So it either needs to be set to session or eventual. These are the only 2 consistency levels that are actually supported by the dedicated gateway. And this is because the consistent prefix and the strong and the bounded staleness modes are not supported by the dedicated gateway today. So if you want to make requests with those consistency modes, don't worry, they will still totally work, but they will bypass the gateway cache and they will go directly to the backend nodes. So again, any consistency level is possible, but if you want to use the integrated cache, it has to be session or eventual. Now, session is the default consistency level for all Cosmos DB accounts. So if you haven't changed your consistency level, you don't need to do anything in code. But if you have changed your consistency level for your account, you can configure this level either at the client or the the request level. So even if you want, your whole application to use a different consistency mode, you can still use the integrated cache with some subset of operations that you configure.
Very, very cool. We're moving on along. We're talking now about updating our SDK code that we're going to be using. And I think next we're going to be talking about how to actually implement those updates. Am I right here?
Yeah, exactly. So here we've showed a sample connection string. Of course, I'm not pasting my real connection string here, but you can see what the structure looks like. So the connection string structure is really the same as a traditional connection string that you might be used to. We still have our account endpoint. It's going to be your Cosmos account name, but this time instead of .cosmos.azure.com, we have this .SQLX thing. So what is SQLX? SQLX is just another name for the dedicated gateway. So when you're actually making a request to the dedicated gateway, you need to make sure that the endpoint that you provide is the correct one so that Cosmos DB knows where to route your request. And lastly, you'll have your account key. This account key is the same primary or secondary key for your account. So the dedicated gateway doesn't have any special key. Now, to get this connection string in the portal, if you go to the keys blade where you would normally look for a connection string, after you've configured your dedicated gateway, you will see two new options here, one for the primary and the secondary connection string for the dedicated gateway. So that will be called out for you. You don't need to construct this yourself, but we just want to show you what the structure looks like.
Cool. So what I'm getting from this specifically is that the actual configuration isn't far off from using a standard connection string. We're just kind of putting in, a URI that has some authentication information. Am I right? It's almost the same.
Yeah, exactly. So the authentication, actually, that's a really good point. So authentication with the dedicated gateway only supports the account key. If you're used to, the traditional .NET SDK, you know that you can also authenticate using managed identity and Azure Active Directory. That is not supported with the dedicated gateway today. So if you're connecting to the dedicated gateway integrated cache, you do need to use this account key, and this is the connection string that you would use.
Gotcha. So Justine, I know the next thing we're going to be talking about are configuring point read operations. And I know that this is part of the integrated cache, and I'd love to hear a little bit more about this if you would mind.
Yeah, exactly. So for point reads, as you know, either point reads or queries can be served from the cache. So the point reads would go against that item cache that we mentioned in the beginning. And to configure a point read to use the integrated cache, you really don't have to do much. Your code could look exactly the same, but if you did want to change your consistency level or a cache staleness, which I promise we'll dive deeper into what cache staleness means later on in this session, you can use the item request options object to actually do that. So what does that look like? This is a code snippet, and we'll dive into Visual Studio and give a real demo in just a minute, but this is what the code would look like. So you can see here, I have my ID and my partition key that I'm going to use for my point read. I have my item request options object. I've set my consistency level to session. Again, session is the default. So if you didn't change the default for your account, you don't even need this. And then I can just go ahead and make my point read. So your code, in theory, could be, very similar or exactly the same as what you already have.
Cool. And I'm curious about how are my charges kind of represented here with this portion? I think it's request charge.
Yeah, exactly. So if you want to see what your request charge was with the dedicated gateway, you can find that the exact same way as you would for any request. So all of the diagnostics available to you are exactly the same. So in this example, I'm looking at response.request charge to see what the request charge actually was. That 0.00 is just a formatting trick. So making sure that we get to the nearest cent. So this is how you would find your request charge, and we'll show an example of what that looks like, what the request charge is for query or for point reads, I'm sorry, that either hit or don't hit the cache in just a second. But before we get to that, let's talk about configuring queries. So we talked about the item cache and how a point read looks. What happens for the query? It might not be a surprise. This is very similar for queries as it was for point reads. So instead of the item request options, we have a query request options. This is what the code snippet looks like. So I have my SQL query here. I'm just selecting everything from my products container and my query request options. This time I'm setting the consistency level to eventual. So remember the two consistencies that are supported are session and eventual. And then I can just issue my query against my container. And I have my feed iterator here. If I want to actually iterate over that to execute this query, this is what the code looks like. But let's actually dive into Visual Studio and let's show a demo of this live. So
let's do it.
Yeah, this is the fun part. This is what everybody's been waiting for, right? So I'm going to dive into Visual Studio, and the code for this project is very heavily based on the code snippets that I just showed you. So if you want to try this at home, all these code snippets are available in the Learn module itself. And I'll just walk everyone through this briefly. So first here, I'm getting my Cosmos connection. I've named this my Cosmos dedicated gateway connection. And this means that it has that .SQLX in my connection string. So this is very important. The very first thing that you should check if you think your requests aren't actually hitting the dedicated gateway is my connection string actually for my dedicated gateway and not just for my account? This is probably the number one most important thing. Next, we'll get into our main function. And here I have my Cosmos client options. So this is equally as important. The connection mode I'm setting to gateway. So if you're using the .NET SDK or the Java SDK, the default connection mode is actually direct. And this means we're using TCP to go direct to those backend nodes. We would bypass the gateway entirely. The integrated cache lives on the gateway, so it's very important that we use gateway mode if we want to use the integrated cache. Now I'm just setting up my client, getting my database, and we'll go into this test item cache function. So this function is super simple. First thing I'm doing is I'm getting my container. I've set my doc ID to 1. So I'll show you what this container looks like in just a second. I have 2 documents. Literally the only property in there is the ID. The ID is set to 1. So keeping this super simple. Here, I've set my request options, consistency level to session. So remember, session is the default for your account. I didn't change the default for this account, so I don't technically need this here, but I wanted to make it really explicit to show you guys how to change this should you need to do so. And then I just have 2 read item asyncs. So I'm passing in my doc ID. My doc ID is the same for both of these calls. And I'll go ahead and print that response charge here. After my second call, I'll print it again. So let's go ahead and run this program.
Go for it.
And of course, it'll take just a second to start up because I'm sharing my screen. And every time I do a live demo, Visual Studio likes to be super, super slow for me.
Just while it's running, I once had a demo. I think I was in Stockholm at a Learn Live or a Microsoft Ignite, the tour. And in the middle of my demo, completely blew up. Just my laptop died on me. I lost my place. And I basically just, kind of did what you do. You kind of like wave and smile and you get to moving on to your next place when you can. But anyway, speaking of your build completed or at least your build is going right now. You want to tell people what's going on?
Yeah, totally. So here you can see all the print statements that I had. My first point read request happened up here, and my RU charge was 1. So point read for a 1 kilobyte or less document is 1 RU. So that's what we see here. But the second line, so the second time I read the exact same document, I actually was charged 0 RUs. This is because it was served from the cache, which is great. All requests that are served from the cache cost 0 RUs. Now, without changing anything, if I go ahead and run this one more time, we'll see what our new RU charges are.
Mhm.
And of course, this is taking really long time. This is because my machine is super unhappy. I have a lot of stuff running, sharing my screen. But here we go.
And you do it live, right?
Yeah. So now I ran this again, and you see, the first request charge is still 1 RU, but I would have expected that to be cached. So why is this 1 RU? This is because I have my consistency level to session. So when I actually restart my application, I am in a new session, which means I need to go back to the back end and get my data. So there's 2 things at play here. You have your cache staleness, and you also have your consistency. So if I were to actually change this, instead of using session, if I were to change this to use eventual consistency,
Mhm.
and if I run this again, this time, instead of the first query or the first point read costing 1 RU, hopefully this time they both will say 0. And again, this is because I have different sessions for, different runs of a console application. If you have a long-running application, say like a web app or something, the session for your user will be preserved, and it won't be, every couple seconds you have a new session. Obviously, the session will look different for every application. But in this case, we can see when we switch to eventual, we were able to get 0 RUs for both of those reads because they were in the cache and our consistency matched. So that's what the item cache is all about. But what about the query cache? So let me just comment out item cache, and let's take a look at our query cache.
Okay.
So this is really similar. This time I'm looking at my container 2. Container 2 has a lot more documents in it. I have 200,000 documents, and they have a much bigger structure. So let me pop over to the Azure portal, and let me show you what both of these containers look like. I promised I would do it, and I forgot. So this is container 1. There's literally just 2 documents in here. The ID that I'm reading is super simple, super basic. Container 2 is a little bit different.
Mhm.
So this is my document for container 2. This is configured to be like a product catalog of sorts. So I have an ID, I have category ID, category name, SKU, a bunch of stuff. So these categories are configured to be like a bike shop. So the different categories that are here could be, shoes. I think that, tires and tubes,
Unlicensed
brackets.
unlicensed cheese, I think I saw before in that first document. I
Yeah,
personally
so that's a good call out. So the category names I have
Mhm.
configured to be a set of 16 categories for a bike shop, but the rest of the data was generated using a really cool library in .NET called Bogus, which generates random product data. So intelligent plastic ball, this is just a randomly generated name, and then we have our randomly generated descriptions and a bunch of random tags. Just to give these documents some weight to them so that we can really
Sure.
see the benefit of the cache. But yeah, that's funny that you call that out. We
Yeah,
definitely have weird stuff in this container.
one of the hardest things that you do in technology is naming them
Yeah,
sometimes.
yeah,
So at least you have a library that'll help you give some silly names when you need
yeah. I'm naming everything intelligent plastic ball from now on.
them.
All right, so now that we know what the container looks like, let's hop back into Visual Studio, and let's take a look at what we're doing. So the reason I wanted to call out those categories is because of the query that we're going to run. So this query, my container was partitioned on ID, so this will be a cross-partition query. I want to show you what this looks like on a query that is going to be a little bit more expensive. I'm looking for a category named components pedals. And here I'm setting my query request options. My consistency level is going to be eventual. And now I am issuing my query here and actually iterating through all of my results. You can see each time I'm adding up what my total request charge is. And I'm also going to go ahead and print the request charge for each iteration. So when I go ahead and run this, we'll see a bunch of request charges. And then at the end, we should see our total request charge for this query. So I'm going to go ahead and run this. Now, the first time I run this, it should actually hit the back end. So this is the first time I'm running this. We don't have it stored in our cache, and we need to go and actually populate that cache. So let's give it a couple seconds for my computer to warm up and actually execute this query for us. And we should start to see all of the round trips for this query. Again, it's a cross-partition query, so we're seeing a bunch of round trips here. We're getting a lot of data from all of our physical partitions. This container was configured to have multiple physical partitions, so not a single partition query. And we have a lot of data in here. I think I mentioned there's 200,000 documents. All right, so here we have finished our query, and we can see the total query request charge was 996 RUs. That's a lot of RUs. I don't know about you, but I would love to save having to, pay this request charge every time we execute this query. What do you think?
Yeah, absolutely. We want to save a couple of dollars here and there if we can.
Yeah, let's do it. So let's run the query again, and let's see this time. Hopefully we should be able to use the cache, and maybe we'll see the request charge be a little bit lower.
And ultimately, that's the whole point of this, is to be able to read from the cache so that we reduce how hot our actual backend is using Cosmos DB. We want to use this to kind of throw it in front, so we're not doing all these direct requests to the database, and we're utilizing the cache to return these items and reduce the level of performance, or I should say increase the level of performance by reducing the amount of queries that go directly to the database.
Yeah, exactly. So this time you see I ran the exact same query and we see 0 RU. So this is great. This is what we want. Our cache is working as we expect, and we're not paying for queries that are repeated, which is awesome. So I want to show one more demo, and this demo will also, it will be similar, but we'll also look a little bit at the latency. So I'm going to go ahead and run this demo, and we can show you what it looks like a little bit more comprehensive way, and we can run this performance demo.
Very, very cool.
So let me wait for this application to warm up.
Sure. While we're doing that, hey, Jason, can you bring up my screen for a second? I just want to remind everybody that there's some really great information available to you, including scenario-based labs and just general labs. You can go ahead, you can start heading, just put your browser to github.com/azure-cosmos-db. You can get all sorts of really great use cases that you can go ahead and the scenario-based one that I really think is great is the IoT one. And in the case of an IoT, where you're reading the documents that have been stored, using a cache in front is going to be really, really important, especially when you're talking about low-end CPU devices that are doing these connections. You want to make sure that they're getting reads back quickly if they need to have some sort of information brought back to them. Anyway, I just wanted everybody to kind of have a little bit of info on where they can use these and actually see them become useful. So anyway, how's your demo doing?
Yeah, we made it. Thanks for buying me a little bit of time there. So
I'll charge you some RUs for it.
Yeah, seriously. So let's go ahead and initialize this demo. I just entered a 1 to initialize. So what we're going to do is we're going to create a new container called container 3 in my account. And I'm going to go ahead and populate 1,000 items. So we're going to do a bunch of writes into this Cosmos container. Now, these writes, the data will be stored in the cache, but of course, as a write, we're not saving any RUs on our writes. So the writes need to go to the back end and actually write the items themselves into the container. So we're just doing bulk inserts so that we can have some data to really show you the power of our queries. So now that we've initialized it, let's go ahead and press number 2. And this is going to run our performance demo. So we're going to show you 5 different things that we can do with the integrated cache. The first is more writes. So we're showing you 100 writes. We printed the latency for each of them. I do want to call out my machine is running a little bit slow today, as everyone can see. So typically the latencies are a little bit lower. To get the best performance on Azure, you really should be running everything in a VM. So I'm just running this locally on my machine. My machine is not very happy. If you run on your machine, hopefully it will do a little bit better, or optimally you're running this in a VM, right? So
Or you
just
can run it like if you're using something like VS Code, you can use like a build container as well, if I'm right, so that you can offload that like build CPU requirement in memory. I mean, this makes total sense to be able to run it locally, but I know that there's some really great options to do your builds that VS Code actually comes to you with.
Yeah, definitely. Great call out. So this first test that we ran is actually doing point reads. So this is without caching. So this application is configured with both of my connection strings. I have my connection string just for my regular Cosmos DB account, and also my connection string for my dedicated gateway. So the first set of tests is using point reads for not using a dedicated gateway. These are just normal point reads. Of course, the latencies are a little bit high. We've already mentioned, my machine isn't the best, so latencies will be lower. They actually were lower when I was running this previously, so that's kind of a bummer. But we can just see what the average latency was. So our average latency was 29 milliseconds, and our average request units cost about 1 RU. So this time, if I press another key to continue my test, we'll actually see how our latencies and our U charges are with the integrated cache. So we could see before it cost about 29 milliseconds latency. Now we're at 34. Typically when we run this, the latencies will be the same or a little bit lower. For point reads, you're not saving that much latency since reads on Cosmos DB are already really fast, especially point reads. So typically the integrated cache, it won't give you that much latency, but it will save you RUs. So I spent 100 RUs for my previous queries, or for my previous point reads. Every point read was 1 RU, and I did 100 of them. This time it cost me 0. So while the latency is maybe similar, you really are saving on request units.
Very, very cool.
Yeah. So now with queries, we should see a similar pattern, right? So we see what is our latency for these queries. This query that I'm running cost me 39.6 RUs. And if you're interested in the query that I'm actually running behind the scenes is selecting the top 10 from a set of IDs where it contains the uppercase name, Tim. Tim is the PM that actually wrote this demo. He's not with the company anymore, but that's what the query is doing, if you were wondering. And we can see without the integrated cache, it took about 47 milliseconds, and it cost us 39.6 RUs each time. So if I press another key and show you what this looks like with caching, this time we actually did save on the latency. So this is more what we expect. We are almost 10 milliseconds faster, and our request units are 0. So this is really important. Again, with those repeated point reads or repeated queries, you really can have a potential to save a lot of money.
I like that.
Yeah, and that's all of our tests. So we just output kind of the results there. And the other things in this demo are really just repeats, a deep dive into the point read and deep dive into the query. So we can go ahead and exit for now. And this really shows you the power of the integrated cache and how you can use it to save yourself money and a little bit of latency too.
Very, very cool. So I think we're at the point now where we're almost close to our next section. Am I right? And we're talking about cache staleness.
Yeah. So I talked a lot about configuring the cache staleness. I promised you that we would get to it. And here we are. We finally made it. So what is the cache staleness? Obviously, if I have a cache, I don't want my data to just sit there forever and never get updated. We could serve, really out-of-date requests, and we don't want that. So we want to be able to tune the cache staleness for each item, and this is the place to do it. So by default, if you do nothing, like my previous examples, I wasn't passing any cache staleness, the data in the cache will be there for 5 minutes. And then after that 5-minute period, we'll have to go back and refresh if we get the same request. But what if we want to fine tune this for our workload? So the way that we do that is in either the item request options or the query request options. So remember, I was passing in the consistency level. We can also pass in the dedicated gateway request options, and we can create a new object. And this is where we configure that max integrated cache staleness. So this can equal a time span either from a certain number of minutes or from seconds. It all depends on your application. And the guidance here is to really configure this to as long as is tolerable for your application. So the longer the cache is around, the more staleness that you tolerate, the higher chance that those repeated point reads and queries will actually hit the cache instead of having to go to your backend database. So this is really important because, of course, if we go to the backend, it costs you RUs. We want to save you as many RUs as possible. So setting this staleness to as long as you'll tolerate will really do the best at saving you money.
Sweet, sweet. That's what I want. I want to be able to do this and save a few dollars and cents.
Yeah. So for the queries, configuring is exactly the same. We have our dedicated gateway request options. This example does from seconds. So this might be a little bit difficult to kind of keep in your head, like what is the process? What does this actually mean? How does this max integrated cache staleness affect the cost of my queries? Mm-hmm. So let's go through a quick example of a timeline of some requests. So first, we have query A. At time equals 0, so 0 seconds, we're going to run query A. And with query A, we're going to set that max integrated cache staleness to 15 seconds. This request will actually return the results from the backend and will populate the cache. We don't have anything in the cache yet because this is t equals 0. Everything is fresh. At the same time, we're going to run query B. And for query B, we're going to set the max integrated cache staleness to 30 seconds. So this really highlights that you can set the staleness differently for each query, and it also works for point reads as well. And this really gives you fine-grained control. You don't need to have the default value work for all of your items. You can fine-tune this according to your needs. Now, query B will also return the results from the backend and will also populate the requests. So now at t equals 10, so let's say 10 seconds have elapsed, I'm going to run query A again. My max integrated cache staleness is still 15 seconds. In this case, I'm going to return my results from the cache. We're within that 15-second cache staleness window, so 0 RUs. Yay, we just saved ourselves a bunch of money. That's great. At the exact same time, I ran query B, and query B, again, has that max integrated cache staleness at 30 seconds. This is also served from the cache, so it also cost us 0 RUs. Now, a couple more seconds have gone by. Now we're at t equals 20 seconds. We're going to run query A again. And remember, query A has that max integrated cache staleness set to 15 seconds. So obviously, we're past that 15-second window. So we need to return our results from the backend, and we'll actually refresh our cache. So this query, this execution of query A will cost the normal RUs that it would have cost before. We weren't able to use the cache this time. But at the same time, we also ran query B. Query B has 30 seconds. So this is a longer cache staleness. This means that query B is able to return the results from the cache again. So we got 0 RUs again. And lastly, at t equals 35, we're going to run query B one more time. That max integrated cache staleness, still 30 seconds. And we're going to return the results from the backend this time, and we have to refresh our cache. So unfortunately, we've hit our staleness. 35 seconds is longer than 30 seconds, so we need to do the refresh. But this really just shows you the timeline of the request and how this max integrated cache staleness is really, really important when you think about fine-tuning your RUs.
Gotcha. Well, you know what, Justine, we've been doing this over an hour so far, and we got a little bit left. Just a little, everybody. I know you want more and more, but we got a little bit left. And one of the next subjects that I really want to hear about, because I used to work in ops and SRE, is being able to monitor the integrated cache.
Yeah, we definitely want to get to monitoring. It is super important, and we will get there. I want to show, in addition to the timeline, I want to show briefly another demo. So we'll just pop back into Visual Studio for 1 second, and we'll show one more thing. So instead of our test query cache, let's actually test the cache staleness. So this demo is super, super simple. It's basically the exact same structure as our point read demo. But this time, we're actually going to configure that max integrated cache staleness. So I've set my cache expire seconds just to 5. So I don't want to make you guys wait around for 30 seconds or a number of minutes just to prove that this works to you. So let's set it to something low. And here is where I've actually configured that. So in my item request options, I have my dedicated gateway request options. I'm setting max integrated cache staleness to this time span. Now, this code should look really familiar as before. We have 2 point reads here. We're reading our same doc ID, so that's doc ID 1. And we have eventual consistency on this request. We have 2 of these responses, and then I'm going to go ahead and sleep for 5 seconds. So we're going to wait for that cache to expire. And then I will issue 2 more queries against doc ID 1. So we should see the first query should cost 1 RU. The second should cost 0. After our 5 seconds have expired, we should see another 1 RU charge and then another 0. So let me go ahead and run this demo. And this is the last time I have to run something in Visual Studio. So for all of you who are tired of waiting for my machine to build and clunk along, hopefully we'll be done with that soon.
I have to requisition you a faster machine before we do our next session.
Yeah, so let's just wait a couple more seconds
Sure,
for this, and we see our point reads here. So our first point read, exactly what we thought, did cost 1 RU, and then reading again cost 0 because we were able to utilize that cache. But after our 5 seconds expired, we had to pay the RUs again. Our staleness expired, so we need to go back to the back end and actually refresh that data. But point read 4 was able to use our cache with 0 RUs. So that's just a super quick demo showing you live how max integrated cache staleness actually affects your workload.
Sweet, sweet. So we've gone through a lot of these scenarios. You've demoed a whole bunch of stuff, and I mentioned monitoring before. Sorry to jump ahead a little bit more.
No worries.
But I just would love to hear, like, how can we get information about performance that come from, like, say, our gateway?
Yeah, that is a great question and a perfect segue. So if you want to see your performance, like which requests are actually hitting the integrated cache, is your cache, configured to be the right size, all of that can be found in the monitoring. So let me switch to the Azure portal and let's go over here. This is my same Cosmos DB account. I'm going to scroll down and I'm going to look for the metrics tab. So this is just regular metrics, not metrics classic. And in the metrics tab, let's just make this a little bit bigger. We have a couple metrics that will really help us measure how our cache is doing. The first important metric that you're going to want to look at is the integrated cache item hit rate. And I'll add one more for the integrated cache query hit rate. So let me just zoom into one of these time periods. I know it's a little bit small, hard to see. So if we zoom in here, we can see the item hit rate is this blue line, and the query hit rate is this orange line. And this is basically saying for all of the requests that had session or eventual consistency, how many of them were actually able to be served from the cache. This can really help you monitor your performance. If you see this number is super low, maybe it's a sign that your cache either isn't big enough, so too many of the requests that you're issuing are new and they weren't able to be stored in the cache, or maybe it indicates, if it's super low, that you don't have enough repeated queries. So remember, the cache only serves repeated point reads and repeated queries. So if you have low repetition, obviously the hit rate will be low.
Great. So you have anything else here you'd like to show me, or is this basically
Yeah, I have a bunch more metrics to show you guys. So let's go ahead and take a look at another set of items. So first, I'm going to look at the integrated cache evicted size. So you can see this is 0, right? My integrated cache, I did pick the smallest one, so I have 16 gigabytes. But the amount of data in my account is really small. I have less than 1 gigabyte of data. So nothing was actually evicted from my cache yet. But if you have a lot of data, you might see some items be evicted. So looking at this evict rate and the size of data that's evicted can really help you fine tune if your cache is the right size. So if your evicted size is really high and your hit rates are low, that is an indicator that maybe your cache isn't big enough. If you do increase the size and it doesn't increase the hit rate, then maybe it's an indicator that your reads aren't actually repeating themselves and maybe the cache isn't a right fit for you. But there are a couple other metrics to monitor the overall performance of the cache. So let's look at 2 more. Let's look at the integrated cache item expiration count. So you can see I ran this earlier, and this is those items that expired. So remember, I set my max integrated cache staleness to 5 seconds earlier, and it expired, right? So this is that expiration count, the number of items that actually expired from the cache. And similar to this, we also have the query expiration count. So I don't have any queries that expired in this time period, but I had some earlier today. And this is how you can look at that as well. And lastly, you might want to monitor the dedicated gateway itself. So we've been talking a lot about the integrated cache, but of course, the integrated cache is nothing without the dedicated gateway that it runs on. So there are a couple metrics for the dedicated gateway that you can use to make sure your dedicated gateway nodes are healthy. The first thing I want to look at is the dedicated gateway requests. So these are all of the requests that were actually sent to the dedicated gateway. You can see I sent a bunch of requests to the gateway. This is sort of, any request that hit it. So this could be my item cache, my query cache, etc. And after we've looked at, the total number of requests, I might want to monitor the health of my nodes. So let's take a look at a couple others. Let's look at our dedicated gateway CPU usage. So remember, we said that you have multiple nodes in your dedicated gateway cluster. Now, these metrics are not specific to any individual node. So this will actually be an average across all of your nodes. And you have different aggregation metrics here. So you can have average, max, or min. You can see my CPU is basically 0. So I am not using this cache very thoroughly. I'm, have pretty low utilization because I'm just doing a couple really simple queries. But we can actually see my memory usage, and this should be hopefully a little bit more interesting. And you can see I have just under 1 gigabyte of data. So these two things, and again, I only have one node in this cluster, so these will all be the same, but you can look at the max, min, average, and these metrics will really help you debug your dedicated gateway itself and really monitor the health of the gateway.
Very, very cool. So I think we're down to about our last 15 minutes. And I know that we've got some things that we want people to kind of let us know what they've learned. And so we've got our knowledge check. And when we do our knowledge check, we're going to give you a few minutes to go ahead and actually answer the question. And we really want to hear from you because we want to know what you gained from watching all this and hearing all this. So both questions are published. They're in the actual Learn module, but we're going to cover them right now. And so the first question I'm going to ask Justine, the first question. In the .NET SDK for Azure-cosmos-db SQL API, how should you configure this, configure the Cosmos Client Options Connection Mode property so that your application can properly use the integrated cache? So we've got 3 answers here. We've got configure the connectivity mode to connection mode direct, connection mode gateway, or you leave the connectivity mode to the default value. So if you'd like to go ahead and vote on your answer, please either use the QR code if you're on mobile, or you can go ahead and go to aka.ms/polls, where you can give us your answer. So I know we've got some people who have already started answering. We're going to give you one more minute. And while we're waiting for you, just want to remind you all, you can go to this particular Learn Live, or I should say Learn module. We'll have the URL for you again. It's going to be in the notes. It's right there below the both of us. So you can go to that particular URL and you can follow along or do it at a later time. So Justine, I think we've given them a little bit of time.
Mm-hmm.
Why don't we go ahead and take a look at the answer?
Yeah, so let's talk about all of the options. The first option, option A, configure the connectivity mode to connection mode direct. So I do remember that the integrated cache runs on the dedicated gateway. And I know that the gateway is, sort of the front end for Cosmos DB. It needs to handle all the incoming requests. I believe that direct mode uses TCP connectivity to go directly to the backend nodes, which sounds like it might bypass the gateway. So I'm not sure about direct mode. I know that we need our gateway to use the integrated cache. So I'm not sure about A. I think, probably not A. If we look at B, configure the connectivity mode to connection mode.gateway, that does sound like something, that we might want to do, right? This is running on the dedicated gateway, so maybe it's B. But before we decide, let's also think about C. So leaving the connectivity mode to the default value. Now, this is kind of a trick question because I know that there's different default values for different SDKs. We have mentioned in the title that this is the .NET SDK though. So the .NET SDK's default is direct mode. And because of that, I think I'm going to go with B. Let's see.
Yeah, I think I'm going to go with B, and you're right. And we're both right. And so, yeah, I mean, we've gone through this module. I think at this point we should know this. And I want you to head back over to aka.ms/polls because we've got one more question for you. But as you can see, or as I said, you're going to use that connection mode.gateway because you want to utilize the gateway. So we've got our next question, and we're going to just put it up there for you for a second, let you head over to the QR code, let you navigate your browser over to aka.ms/polls. And then you can answer this question, which is, which property of the item request options class should you configure to manually adjust how long items will remain in the cache? So what are my options here, Justine? Let's go through them one at a time. So you think it's session token?
So I remember talking about session token in relation to the cache, right? We definitely want session consistency. So session token, maybe it could be related, but I think I remember in the .NET SDK that the session tokens are actually handled by the SDK for me. So I don't think that we need to do anything special to the session token especially not to configure how long it remains in the cache. So I'm not sure about A.
Yeah, and I'm seeing B, and it's saying consistency level, and that's another potential option. But I don't really think that that's where this is going because you're not worried really now about setting consistency in the data that's written and read. What you're really more concerned with is how you're actually going to get it into and ingest it, and making sure that you're utilizing the cache to the best that you can. And so that leads us to the next one, which is dedicated gateway request options max integrated cache staleness. Do you want to just give me like a quick explainer on what I just said?
Yeah, totally. So the dedicated gateway request options max integrated cache staleness, what a mouthful. It is the longest answer by far. But if we think about what the max integrated cache staleness does, it actually does allow us to determine how stale we will allow our data to get in the cache. So if I think about, what I need to configure to adjust how long items will remain in the cache, and I think about staleness, that really sounds like a good fit to me. I think it's C. What do you think?
I'm going with C.
Cool.
I'm going with C.
Let's see if we're right. And
Hey.
we are right. It's C. And it sounds like most of our audience got that as well. So thank you guys for taking these polls with us and humoring us a little bit. It's always fun, and we're really glad that you guys learned something.
Yeah, absolutely. So I think it's time to get to the part that that makes us sad because we're almost finished talking with y'all.
Yeah.
But let's remember what we and summarize what today's learning objectives were. And I said at the top end, we want to teach you how to implement the integrated cache, and then we wanted to configure that actual integrated cache with the options available. And we just saw in our questions a couple of those options that you can utilize within the SDK. Specifically, what you saw today was .NET. So, Justine, I want to learn more about this. Ooh,
Yeah,
you've got that ready for me.
Yeah, so if you want to learn more and you want to go through this module, please go to this link or go to the QR code, take the module and see for yourself. I hope that we've done it justice, but it's always good to revisit and really reinforce that learning. And be sure to also join us for the next session. Oh, this is actually this session. Sorry, this is the learn. Got ahead of myself for a second. Yeah, this is the link for the current session.
Yes, and but don't miss, because this is part of an entire long series that we've been doing, 24 episodes in total. And the next one's going to be measure performance in azure-cosmos-db SQL API. And so we talked a little bit about, monitoring. We talked a little bit about performance. We'll look a little bit deeper into that with that next particular module. And so there are QR codes there for more information. Take a look at it. And please just try to join us for our next one. And we've got one more little tidbit of information. We talked about it at the top of the show, but certified. You can get certified. You can take the exam that gives you a developer specialty certificate that you can print out and hammer on your wall, or you can put it on your LinkedIn. You can share it with your friends and neighbors and make your enemies envious. Anyway, go get certified. You can show everybody in the world that you know enough about Azure Cosmos DB to get that developer specialty. And I think that's really the gist of it today, Justine.
Yeah, that's all we have today. Thank you, Jay, for joining me. This was really fun, and I know I learned a lot, so I'm really hoping that the audience did too.
Yeah, this was a pleasure, and I really, really appreciate getting some time. And I think I'm at that point where I like to always say, let's give everybody the big wave goodbye. Thank you, everybody.
Bye. Thank you.
See you next time.